Thank you. Thanks for the introduction, Juliana, and thanks everybody for being here. So today I'm going to be talking about the Vermont Lay Monitoring Program. So the title of my presentation is Methodology Matters, Modifying the Vermont Lay Monitoring Program to Improve Lake Assessment. So currently I'm with the University of Vermont Lake Champlain Sea Grant in partnership with the Vermont Department of Environmental Conservation, Watershed Management Division Lakes and Ponds Program, which has traditionally coordinated the Vermont Lay Monitoring Program since 1979. So I'm happy to continue as the coordinator in this joint partnership. And so my title with Sea Grant is Lake Monitoring and Community Outreach Coordinator. But again, I'm also the Lay Monitoring Program Coordinator. So I'll get right into it. And there we go. So the presentation today, I'm going to be first talking about just giving an overview of the Vermont Lakes Lay Monitoring Program and sort of its history and protocols up to this year. Then I'll go through some of the Lay Monitoring Program, which we call LMP for short. I'll go through some of the data that's been collected recently, the reporting that we do, and then the assessments using that data that we make. And then I'll talk about a pilot study that I started last summer to look at our methodology, our sampling protocols, to see if there's opportunities for improvement to help us with lake assessments. So I'll show some of those analyses, give a sort of a summary, and how that can inform us for next steps for 2023 as we update the protocols for the volunteers. So the Lay Monitoring Program goals since 1979 has been to equip volunteers, or lay monitors, as we call them, to conduct periodic lake water quality sampling from their boat using quality assured methods. That's from established sites on the lakes. So it's been the same sites during the length of the program, typically from the central or deepest part of the lake. And we're looking to establish baseline water quality conditions of Vermont lakes, specifically during the summer recreation season. And that's to kind of help out with some of our other sampling programs. So here on the right, I have a graphic showing spring phosphorus monitoring and spring monitoring that our staff does, and showing some of the trends in phosphorus concentrations over the years. So this kind of fills in some of the summer data needs. So we're tracking long-term nutrient trends in Vermont lakes and assessing the monitoring data for compliance with Vermont Water Quality Standards. And we're also educating lakeshore homeowners and lake users about lake ecology and stewardship. And the link to the lay monitoring program is on the bottom of this screen. I can provide that as well afterwards. So as I said, the program began in 1979, and up until this past year, the protocols work so that we ask volunteers to sample about weekly to sort of every 10 days or so, from Memorial Day to Labor Day, and looking for a minimum of 8 samples in total to calculate a summer mean for our long-term trend analyses. So the basic sampling that a lot of the lay monitors started out with was just using a Secchi disc, which is pictured here on the right, which is it's a measure of clarity or transparency in the lake, and it's been used for quite a while now in lake monitoring. It's very simple and cheap to use, a little bit subjective depending on the person using it, as it's a visual observation. But since it's pretty standardized in lake monitoring, it's a good proxy for water quality in general. So the supplemental sampling, which the majority of our volunteers do at this point, trying to get as many lakes to collect water samples as possible. So that involves collecting water samples using a depth integrated hose. That's the old protocol at twice the Secchi depth. And then we send those samples in to our lab to test for total phosphorus, which is the main limiting nutrient in our freshwater systems. and chlorophyll A, which is a measure of, it's a pigment in algae and plants. So we're looking at trying to get an idea of algae concentration in the water as well, which will relates to the actual clarity. So the volunteers also complete a lake sampling form and a user perception survey traditionally, which is kind of looking at algal observations. So now we have a lot more volunteers that are trained to be cyanobacteria monitors as well, and to help report that to the state, so we can start tracking some visual observations of cyanobacteria. So as far as the staff responsibilities, it's a lot of fun in the summer. That's me on one of the volunteers' boats, actually. So I was actually asked to go out that day to do the sampling, but normally our main responsibilities are to equip and train new volunteers. We also try to visit as many volunteers during the summer as possible, at least once within a couple of years, and that's to do quality control sampling to make sure they're following the protocols correctly, and also so we can do some side-by-side duplicate sampling, and I also collect additional parameters while I'm out there. So we also pick up the samples from the lay monitors all around the state on a bi-weekly basis, and we take them to our lab and we log them in for testing there, to try to make sure we get the samples in before the holding time expires. While we're out there, and also through email and phone, we answer questions on sampling, lake ecology, and management as well, which is something we've been doing a lot more recently to get lake watershed action plans going on individual lakes. So using our monitoring data to inform those plans. And then we process all the data at the end of the season and do some analyses, preparing annual reports and assessments. We're also responsible for the quality assurance project plan, which is approved by the EPA to make sure our data is usable for assessments. And that's something I'm looking to update. So yeah, we operate statewide. In 2022, we had 83 inland lakes and 8 Lake Champlain stations sampled by lay monitors. 66 of those lakes were sampled as part of the supplemental program for chlorophyll A and total phosphorus. And 45 lakes were visited by LMP staff, mainly myself, for training and/or QC sampling. And I also take water quality vertical profiles at that time to get some more information from the lakes. All of our data can be found through our online data portal called Vermont Integrated Watershed Information System, or IWIS. And there's a link here, and you would just do a site search to look for the lake that you're looking for in the specific site or station. And also on the lay monitoring webpage, I have a section for reports that has links to the data as well as different reports that we put out. So one of those reports is the annual lay monitoring report, which used to be a paper report. I've made everything digital at this point. So you can just click a button and it'll take you to the lake, and you can search for different years up at the top. Or different lakes. And it gives an overview of just kind of the data from the year, calculating minimums, maximums, and the means for that summer. And then it shows you all the data from throughout all the years. And the red box on the right here, I just highlighted because I added our Vermont Water Quality Standards in here for Class B2 lakes, which is most of our lakes in the state, just to give an idea of what the standards are, or criteria compared to results we're getting. We do look at the previous 10 years doing assessments. So it's not just 1 year that determines whether a lake is meeting those standards. But what jumped out after looking at some of these results comparing to our water quality standards is this is a graph here up on the top looking at total phosphorus on the y-axis. And on the x-axis is all the lakes in the lay monitoring program from 2022. So it gives you a comparison of phosphorus numbers. The shaded background is showing low nutrient on the bottom, or oligotrophic kind of range, mesotrophic in the middle, so sort of intermediate nutrients and productivity, and then eutrophic at the top, which is high productivity, lots of algal and plant growth. So I picked out a few lakes here. I'm going to focus on Great Hosmer Pond, which is this green bar here, and the arrow on the right, which is showing some of our highest total phosphorus among the lakes. A few of the others are Lake Champlain and Lake Carmi, which you might be familiar with, which are definitely more productive. And then also Lake Fairley, which kind of stood out because I know that's a bit of a clear lake. Great Hosmer Pond is also a very nice, fairly clear lake in a fairly undeveloped watershed. And then I also have Valley Lake in here, also known as Dog Pond, which is another clear lake. So I kind of stuck out as having these high total phosphorus values, and we see the same on the bottom graph here for chlorophyll, showing fairly high chlorophyll values, especially Great Hosmer Pond, which kind of stood out because I know the water clarity there looks pretty good, and there's not many complaints about affecting uses. So looking at the actual Secchi depths, this is what I was referring to. Those three lakes are also have some of the highest clarity in our state. So we have Secchi depth on the y-axis here, starting from the surface at 0 meters and going down to about 12 meters. And this again is looking at the average summer values for the lakes in the Lay Monitoring Program. So I wanted to try to make sense of that. And we have another type of report called the Lake Scorecard that you might be familiar with, but it kind of gives an overall assessment looking at the water quality data that we have. So when you bring up Lake Scorecard, which is linked at the bottom here, you get this first page, kind of shows you the scores based on a watershed assessment using GIS information. So this is Great Hosmer Pond, which shows a yellow or moderately disturbed watershed, and stressed for water quality standards is still meeting standards, but we knew that there was low dissolved oxygen at the bottom of the sampling site there, at the bottom of the lake. So it gives you some kind of overall information. Then shoreline condition, it's not really well developed, so it's got a good score for that. But there is a water quality trend that's of concern. So if we look into the water quality tab, we start to get a bit more information. This is showing annual means. So on the upper left here is our spring phosphorus monitoring program, which I had mentioned before. It's a bit sporadic. It's just a one-time sample after spring spring mixing. And we actually show an improving trend there. On the top right here is our summer phosphorus trends from the Lay Monitoring Program. It's showing a slightly increasing trend. It's quite variable as well. And these are, again, the means from each year. And in our water quality standards for Class B2 lakes, 18 micrograms per liter is the criterion over a 10-year period. And we're seeing that kind of fluctuate above 18, and especially in the last few years. However, on the bottom left, we see the Secchi depths actually increasing, so kind of improving over the years, apparently, and mostly in the clear oligotrophic kind of range, whereas we have the phosphorus in the more mesotrophic eutrophic range, and same with the chlorophyll, which has a lot of variability and more in the eutrophic range. So with the new Lake Scorecard, you can actually click on the daily means as opposed to the annual means, which is basically just all the samples from that year. And you can see the variability in the summer data here. You know, some really high numbers for phosphorus. The Secchi's kind of it's a pretty big range there from mesotrophic to oligotrophic, and then the chlorophyll is a pretty huge range, pretty eutrophic at times. So we see kind of the similar patterns for Lake Fairley. Although we are seeing an increasing trend in spring data as well, but this huge variability, especially in more recent years, whereas the Secchi depth was showing an slightly degrading trend, but again, in this kind of low nutrient oligotrophic range, and in recent years, it actually has some really high clarities, and then the chlorophyll just kind of all over the place, oligotrophic to eutrophic. So not really kind of agreeing with the Secchi depth all that much. And then we see similar for Valley Lake, a little less data, not as much trends going on here, but we see that variability from phosphorus mesotrophic to eutrophic, but the Secchi clarities are really in the oligotrophic range, very clear. And chlorophyll is kind of ranging throughout, some high readings at times. So getting back to the water quality standards, we have different classes of lakes. Most of our lakes are in class B, as I was mentioning before. So we have total phosphorus here, 18. And that's supposed to line up with these nutrient response conditions, or Secchi depth of 2.6 meters. So anything over that is, would be meeting the criterion for Secchi depth. And then chlorophyll is 7. So, those lakes where the Secchi depth are meeting actually class A1 criteria over 5 meters. But some of those phosphorus and chlorophyll values were over these criteria for class B2. And if we look down here, the qualification is June through September. So it was kind of, the standards were written to be able to use this summer data, not to be exceeded in the photosynthetic depth, or also known as a euphotic zone at a central location in the lake. What exactly does that mean? Well, partly that was the idea of doing the hose samples down to twice the Secchi depth as an estimate of the euphotic zone. But it's an estimate. It's going to differ from lake to lake based on clarity, based on sediment, suspended sediment, and some other factors. And of course, you have volunteers doing the Secchi depth readings, which is going to be a little subjective, and that depth is going to change constantly. So, the definition of the actual euphotic zone is where there's at least 1% of the light reaching down through the water to allow photosynthesis to take place for both algae and plants. So there's a diagram on the bottom here, kind of showing this euphotic zone. You can generally think it's sort of where plants can, the depth where plants can grow down to. It could be a little deeper in certain lakes for where algae can still grow. But it also gets a little complicated where, cyanobacteria can move up and down the water column. They can even rest on the bottom of a lake and pull phosphorus and come up to the surface or hang out in different layers. So the idea of kind of using this twice the Secchi depth to get at where algae might be growing is not always necessarily that accurate. And what can happen, and this is actually on our Lakes and Ponds webpage, and I like it because it shows a couple of different ways to look at the layers in a lake during the summer stratification period, where you have warmer water on top, the epilimnion. You have a decreasing or a change in temperature in the thermocline, the middle layer, and then the bottom layer that's separated from mixing of the upper layers and with the atmosphere is the hypolimnion, and it's going to be the colder water trapped at the bottom. And then when we look at light zones, you have the photic or euphotic zone, again, kind of representing where algae and plants can grow here. And then this aphotic zone where there's not too much growth going on, more respiration. But again, the cyanobacteria can move it between those layers. So just keeping that in mind. And so another thing that can confound some of the sampling using a hose to down to twice the Secchi depth is internal phosphorus loading from anoxic sediments or anoxic hypolimnion. And this is a diagram I took from Peter Isles, because I kind of liked it. It's pretty simplistic. But I think demonstrates the point here. So on the y-axis is basically just showing a cross-section of a lake. So the surface water on the top, the thermocline here in the middle, and then this bottom water is the hypolimnion and sediment on the bottom. And then on the x-axis, we're just looking at a time period from May through September, sort of that sampling period in the summer stratification period. And as time goes on and the lakes stratify, oxygen levels on the bottom, since they're not mixing with the rest of the water, can go down, especially in some lakes that have a high sediment oxygen demand. They might have a lot of organic sediment from previous watershed land uses, or deep holes kind of sucking up that oxygen. And especially if they have algae and are quite productive. And what can happen then is once there's no oxygen left, phosphorus can be released from the sediment through a biogeochemical process, and that can increase in this bottom layer throughout the summer, and then actually feed some of the cyanobacteria and algae, especially hanging out around the thermocline. And eventually, when the lake mixes in the fall, some of that phosphorus can get up into the surface waters, and we can see blooms at that time of year. That's fairly typical in some lakes. And again, yeah, showing kind of feeding the algae at the end of the summer. So looking a bit further into those three lakes to try to understand a bit more what's going on, looking at these bathymetric maps or depth surveys, and these are more recent ones that were done by our staff. Great Hosmer Pond is here on the left, and there's a southern section with a deep hole, which is actually where our station 1 is sampled by the volunteers and myself. A couple other deep holes in the northern section, and the deepest being about 54 feet. And if we think about getting Secchi depths around 5-6 meters or so, you're getting close to the bottom basically when you're doing twice the hose. And here's Lake Fairleigh on the right here, and there's a deep hole in the west part of the lake, and that's also where the samples are taken. And with those Secchi depths are also getting close to the bottom there, and those deep holes can stay stratified sort of longer, have more oxygen depletion, and they can also sometimes contain more of the organic sediments that make their way into our lakes to really deplete that oxygen level and have potential for internal phosphorus loading. And this is Valley Lake. It's an old map, but there's a deep hole, really small deep hole in the middle here, which again can lead to some internal phosphorus loading. So that's some of the sampling that I was doing over the previous years, as I would do these lake visits, and I'd come out and I would have a multi-probe sensors that I would drop down looking at temperature, dissolved oxygen, and I would take nutrient samples and chlorophyll samples from different depths in our lakes. So on the y-axis here, and this is Great Hosmer Pond, we have the depth starting from the surface down to about 14 meters or so. And then on the x-axis is different concentrations based on the parameter. So the red diamond is the temperature profile. So we can see that stratification. We have the warm water on the top, and then the thermocline, which drops dramatically, and then the colder water on the bottom. Dissolved oxygen, the sensor wasn't working, unfortunately, for the first 8 meters or so I went down, but thankfully I did catch the end of the thermocline here and got into the hypolimnion, which is showing basically no oxygen at the bottom, which is kind of the conditions for internal phosphorus loading. And that's what we see with these triangles, total phosphorus in the orange here, fairly low at the top surface, well below 18. Also where the Secchi depth is, and should have pointed that out, that's that circle here, 5 meters. And then I did basically what the hose would do at twice the Secchi depth. And all of a sudden we see this huge bump in phosphorus to 65, which is another indication of internal loading. We see a little bit of that with the dissolved phosphorus, an increase, but not much, because it's probably mainly taken up by the chlorophyll or the algae, as we see that bump going down towards the bottom. And this is fairly high algal concentrations, above the standard. And we see similar results for Lake Fairley. I'm just going to kind of go through these. I do have a lot of slides to go through, and Valley Lake as well. And what you can see in Valley Lake too is, even though we're pretty far off the bottom, but we're still in the hypolimnion, you still get that huge increase in phosphorus. And so that's going to be influencing the hose if we're dipping down the hose all the way that far. So I just wanted to point out, some of the issues I have with the hose. Put this photo up again because this is showing some longer hoses, which aren't fun to deal with. So even though I'm smiling, doing the sampling, couldn't wait to get rid of the hose. So this twice the Secchi depth is a dynamic measurement. So it makes it difficult to assess lakes from sample to sample, as well as comparing lakes to other lakes, because you're having a different sample depth each time. And that can penetrate into the hypolimnion, especially for really clear lakes. And then the depth integrated sample can be influenced by this internal phosphorus loading. So there's a need to do these vertical profiles that I was doing to inform our assessment, but it's not something that the volunteers can do all the time. So again, it's difficult to use these hoses, and they're very difficult to quality control or assure for trying to make sure there's no contamination, as we also use a bucket to put the hose samples into. And there's no way to really do a blank sample to put in like this deionized water to see if there's any contamination from the equipment itself. So the data can be questionable at times, let's put it that way. So I came up with this pilot study to take about 16 lakes who could participate in doing a side-by-side hose sampling as well as surface sampling. And 10 of those lakes I knew had fairly significant internal phosphorus loading that would influence those hose samples. So I wanted to kind of get a comparison there. And then I wanted to correlate the results with Secchi depth, both with and without a view tube or a view scope, which we just started recently using, as pictured here on the right, which really helps with those Secchi readings to make them less subjective, especially between volunteers. It's just me sampling the surface water. This is Lake Morey. So getting into data, I'm going to kind of move through quickly, but this is showing the Secchi depth with and without the view tubes. We have the depth on the y-axis again, starting from the surface, going down to 14 plus meters, and then the dates of sampling on the x-axis. This is for Great Hosmer Pond. So clarity is a little bit reduced in the early summer or late spring, which is to be kind of expected. Then it clears up and stays fairly clear, almost around 8 meters throughout the summer. So you would kind of expect to see similar patterns with the phosphorus and chlorophyll concentrations. So we have those concentrations on the y-axis here, and then dates on the x-axis, as they're higher at the beginning of this summer. And what I have here is the triangles are again phosphorus. closed triangles or the filled in triangles are the hose phosphorus, and the filled in triangle, or sorry, the empty triangles are for the surface phosphorus. So you would expect the hose to be higher at the top, or higher here, and then the same with the chlorophyll. The filled in circles are from the hose, and the empty circles from the surface sampling. So you can see the hose samples definitely have higher concentrations. You see a similar pattern with both, though, that they reduce in concentrations throughout the summer, but we're really seeing that this hose is picking up that internal phosphorus loading, as well as the cyanobacteria that's growing down there. We see similar patterns for Lake Fairleigh. These are pretty good clarities, around 8 meters. And what we actually see is what is probably being an increase in internal phosphorus loading as we're getting closer to the bottom there. And I should have mentioned that the hose samples for Great Hosmer were down to 10 meters to make sure we don't hit the bottom. Whereas Fairleigh, they were going down to 1 meter off the bottom. So that could vary depending on the Secchi depth and also water levels. So we see pretty consistent results for the surface phosphorus staying fairly low and really reflecting those high clarities. We only had hose chlorophyll here, so we did see an increase with that increase in the hose phosphorus. But again, that's just influence from the internal phosphorus loading there. Valley Lake, kind of the same thing. These has really high clarities here. It's a little reduced clarity in the middle of summer. But yeah, those high hose phosphorus readings again, and a bit higher hose chlorophyll readings. And you do see some of the concentrations increase in both as the clarities went down a bit. But again, heavy influence for internal phosphorus loading. So now I'm just going to show some graphs of comparing the hose and the surface sampling to their Secchi depths, and really just trying to see what correlates the best. So the first, on the upper left here, we have hose total phosphorus with Secchi depth without the view tube, and that has the lowest correlation, R squared of 0.2. Moving to the right, we have the hose total phosphorus with Secchi depth with the view tube. It improves the correlation a little bit, but not much, 0.22 for R squared. When we move to the bottom graphs here, and we're looking at the surface total phosphorus with Secchi depth with and without view tube, and we really get much better correlations, reflecting those conditions, kind of what we're seeing from the surface, right? How clear the lake is, and that those surface waters at the upper layers are much lower in phosphorus. So it doesn't make sense that it correlates. We see the same patterns with the chlorophyll, hose versus surface, using the Secchi depth with without the view tubes. The best correlation is 0.66 for R squared. Here is the surface chlorophyll with the Secchi depth. And then we just compare hose total phosphorus and chlorophyll versus the surface total phosphorus and chlorophyll, just because I have the data for 12 of those lakes. We see a better correlation with the surface samples. There's a bit more variability when you're using the hose. And then I also just wanted to show the comparisons of the surface to the hose for total phosphorus and chlorophyll. So, what is the big difference? I mean, for one, when we put all the lakes together here, which is on the right, it's not a very good correlation. We see it heavily favorable. Well, the hose basically results are much higher. When we split it up into the lakes with and without internal phosphorus loading, we can see that the lakes with internal phosphorus loading, you still get this much higher hose phosphorus readings than what's coming from the surface. But the lakes that don't have that internal loading, it's a much better fit here. We definitely still see a little bit higher phosphorus concentrations from the hose, which will be expected as there's, organic matter kind of falling through the water column a little bit. So the least amount would be at the surface waters, but there's a much better correlation there. And we see the same pattern for the chlorophyll. Or lakes without internal loading, it's much higher correlation between the hose and the surface sampling. And then just to show the difference between the Secchi depth with and without the view tube, actually follows pretty nice straight one-to-one line. Oops, sorry about that. And this is showing from the study, the pilot program, and also from the entire lakes program, as I've gotten most of the volunteers view scopes now. So yeah, you're always going to expect, for the most part, a bit higher Secchi depth with the view scope, which is, I think, a more accurate reading. So just in summary, yeah, so okay with time. Looking at the pilot study from this past year. The main takeaways are that total phosphorus and chlorophyll A have the highest correlation with secchi depth when using a view tube and when sampled by bottle grab at the surface instead of by depth integrated hose at twice the secchi depth. And that's what those last graphs were showing. And the reason for this is, I mean, a deep hose sample at twice the secchi depth can pick up additional total phosphorus and chlorophyll A from internal phosphorus loading that can be trapped in the anoxic hypolimnion of certain lakes. And we had 10 lakes in the study that I did out of the 16. And you can see that really when you separate the data for lakes with and without internal phosphorus loading and how that affects the hose sample results. So for 2023, I'm going to move forward with a new lay monitoring program protocol and a QAP that I have to update, which isn't always fun, but I'm looking forward to really updating this program and methodology. So no more hose samples, and I know that's going to make a lot of the volunteers happy as well. So the lay monitors will be collecting just bi-weekly surface samples, so for a total of 6, because based on other studies, it looks like that's, and sort of doing power analyses and other monitoring programs, really bi-weekly sampling is enough to get a good estimate of the summer average, and it puts less of a burden on the lay monitors to try to come up with just 6 samples, so bi-weekly, June, July, and August. And that will be surface water bottle grabs, and I'll keep it optional for now, but also having the lay monitors start to collect deep water grab samples, so discrete depth samples at either down to 20 meters or so. That's the equipment that I just started purchasing, sort of limited to that, or 1 meter off the bottom if it's less than that. And that's to really kind of track the internal loading where it's happening, or other depths in the lake to see kind of what's happening. So that's the equipment that I will start providing this year, but also Lake Association of volunteers can purchase themselves. As a picture of this deep water sampler at the top here is kind of a Van Doren style, for those of you who know that, and it's only around $75. I've yet to try it out, waiting until conditions are safe, but yeah, hopefully that'll work pretty well. And all this new data will be analyzed and assessed for trends by depth, so separately now, and separately from the historical data. So we will have to kind of start new trends, which we'll be able to calculate after 5 years of having this new data. And then we can compare the new trends with the old trends, and we'll have a lot more information to see what's happening in the surface waters, especially, we can compare to other lakes, I think much more accurately. And then we can also start to see what's happening in our deeper waters, the hypolimnion or internal loading that we can start tracking over time, which we haven't been able to do before. And one additional thing I'll be adding this year, I'm still working with the lab to hopefully get it finalized in time, but they have been able to test for caffeine recently, and I'm having them kind of pull out a separate methodology just for lakes so that we can kind of keep it cheap and have our volunteers collect that data, at least as a pilot program at first. So caffeine, and there's quite a bit already published about this, to be used, it can be used as a tracer for human wastewater. So basically in our lakes, we could look at, potential inputs from septic systems, which comes up a lot, questions about, sources of phosphorus, as well as other contaminants of emerging concern, pharmaceuticals, E. coli, but we don't have really a good way to test for that. And this would be sort of lake-wide testing, but it would be something that if we actually did get some positive results and we can compare to other lakes, we could take those results of the towns or lake associations to maybe look further into the condition of their septic systems around the lake. And to my knowledge, there hasn't been that many studies on lakes specifically. I've seen a few on some streams, and wastewater treatment ponds, that kind of stuff. But yeah, not really on lakes as part of a volunteer program. So I think that's probably my time, and we'll leave it at that. So thanks for your time. Thanks for joining, and definitely for questions. My email is at the bottom here.